Hello. I will start with a quick survey. How many of you have a microcontroller-based product and are wondering how to improve the user experience on it? Thank you. You're the best. In fact, I'm convinced. My name is Nicolas Santini. I work for STMicroelectronics at customer support. And I am convinced that the graphical user interface, and not any kind of graphical user interface, not only improve the way the user interacts with the product, but also create a link with the customer, and a strong link sometimes. Look at your smartphone, you are attached to it. And what does it mean to create a link with the customer? It means that for the next generation of the product, they will probably buy it as well. So it's not to be neglected, I would say. So let's consider this magnificent home thermostat, the control panel of a home thermostat. Thank you, DALI, for generating this AI-generated image. So that's why the numbers are completely absurd. Anyway, this is functional, right? You have all the information you need, except the temperature, which is wrong. But assuming that it's the right temperature, you have ways to control the temperature. But let's be honest, you will only look at this one if you are cold, or if you are hot, or if you feel something wrong. Something is wrong with the temperature in your room. You will not go every day looking at it, oh, it's a crap. No, there's no way. On the other side, thank you, DALI, again. If your control panel looks like this, then first you will see immediately that the temperature is wrong, because maybe it will turn into blue or into white. Or if it's okay, it will turn into green. So by blinking of an eye, the blink of an eye, you will see that, okay, I feel cold, maybe I've got some fever, but it's not the temperature. The temperature is right. And you will see also this one every day, so you will look at it. You will not hide it in the corner of the room. You will expose it. Maybe it will become the part of your home decoration. And finally, with this kind of user interface, so using a large display, the evolution of the product is a lot easier, because on the left one, if you want to add a feature, maybe you will have to add a button. Add a button, it's impossible, so you will have to rework the entire interface. On this one, you will have only to maybe implement some software part to make the evolution of your interface. But I was talking about microcontroller-based products. And microcontrollers are not good, are not designed to do this heavy task that is updating a user interface. Updating a user interface means a lot of pixel processing. It's a lot of heavy computation. Depending on the size of your display, the more pixel you have on the display, the highest definition, the more expensive is in terms of processing. So we have to help the microcontroller, and the first idea we can get with is as on PC, in fact. On PC, to drive the display, to drive the user interface, you have a GPU. You have a GPU that is next to the main processing unit, and it's dedicated to update, control, of course, by the main CPU. It's there to update what is displayed on the screen. So the same idea can apply to a microcontroller. So that's the agenda of what we will talk today. First, we will define, and to have all the same vocabulary, what is a GPU, what is a graphical processing unit. Then I put a lot of acronyms in the second step, because it was a too long line otherwise. So a graphical processing unit for graphical user interface on microcontroller units. Okay. How can a GPU help in this task on microcontrollers? Then we will address as well the GPU programming, because it's a more complex device. And we will step to the conclusion. So a graphical processing unit, excuse me, is not a standalone component. And yes, so it's here to assist the main core, but on dedicated tasks. And this dedicated task will be the graphical user interface rendering tasks. but it shares the same memory, the same resources, so the same memory, the same clocking as the core, and it is programmed by the core. So this is the most generic definition, I would say, of a graphical processing unit. And it is dedicated to pixel processing. So the architecture of a GPU is made for simple operation, and such as addition, multiplication, basically that's and access to memory. That's basically what a GPU does. So imagine a GPU is like, imagine your microcontroller is a restaurant. The chef of the restaurant, so in the kitchen, is the main core processing unit, so a Cortex-M, for example. And it knows all the recipes of the dishes that must be delivered to customers. Okay, it's able to slice vegetables, it's able to prepare the sauce, it's able to cook the meat, and he knows all the recipes. But when it comes to deliver the dishes to 100 customers, or maybe 60 customers per second, then the chef cannot achieve it, cannot achieve that on his own, and he needs some assistance. Some kitchen assistant that will be dedicated to specific tasks, such as one assistant will be dedicated to slice the vegetables, another one to the sauce, another one to cook the meat, and the chef will then distribute the task to each of his kitchen assistants. So the chef here is the Cortex-M, and the kitchen assistant is the GPU. That's the best analogy I could find, and I'm French, so food is important to me. So I think it's a good analogy. So let's consider this dashboard. So it will be not the running gag, but it will be repeated in this slide set. So that's the graphical interface we are considering. So it's a dashboard for an e-bike or an e-scooter. And if with only the microcontroller, so the main core of the microcontroller, the Cortex-M, is responsible to update it. It will first determine which area of the display needs to be updated, and then finally process each pixel of these areas on its own. So when it's doing this, if you want many things to update on the user interface, the Cortex will be fixed and will do only that almost. This is not what you the Cortex must address other points to get temperature sensor, program an ADC and all. The Cortex is there to drive your product. It's not there to update only user interface. If you imagine if you add your kitchen assistant, then the core MCU, the Cortex, becomes the chef of the kitchen and delegates all the tasks to the GPU. So the Cortex will be there still to determine which area of the display needs to be updated. But as far as the actual update of this pixel is concerned, it will be processed by the GPU, and then the GPU will be in charge to do it as efficiently as possible because it is architecture for that. But GPU, when we talk about GPU, I was afraid when I heard about, well, yeah, there are some GPUs, MCU. Are you sure? There are several flavors of GPUs that can exist. Because when we talk about GPUs, usually, at least I did, they are famous for 3D gaming. So here I removed the trademarks for obvious reasons. But you will recognize some PC gamers graphic accelerators. And you can see that they are huge. They contain a huge amount of memory, very fast memory. They consume a lot. Sometimes it's you have to double the power supply of the PC to make it run. And you can see as well many fans on them. This is okay. Why not? But on the other side, microcontroller is famous for what? It's famous for being small in size and price, to be simple, to be programmed. It has limited memory. You add only what you need. And it has, of course, some low power capabilities. And I'm not even talking about heat. We do not want microcontroller-based device to generate some heat. So how possibly can we integrate these monsters into a microcontroller? Still keeping the essence of a microcontroller. Before answering this question, let's talk about what is an advanced. There are many words for that: fancy, advanced, rich, smartphone-like graphical user interface. What does it mean, in fact? Let's consider this. So this is still a dashboard for an e-bike or an e-scooter. You can see that you have all the information you need. Huh? You have the speed, you have the direction, you have the mode that you selected, and the remaining battery that OK, it's black and white. And keep in mind that when you're on an e-bike or an e-scooter, you don't want to look too much at your dashboard. You have to look at the road and what is happening around. Here, when you go quickly to the dashboard, you will see only 2 digits on the speed. You will not know if it's 35 or 15. OK. So to enhance this user interface, the first point is to have to be able to display a wide range of colors. Okay, so this means I put 24 bytes per pixel to say that okay, you will not only manage 2-bit black and white for each pixel, but 24 bits. That's not the same amount of processing. And this will allow you to display bitmaps and color gradient effects, such as this one, this color effect, which makes the interface nicer. You also want to have some non-rectangular graphic elements, because the round effect is fancy, is nice. On any smartphone, I will not mention marks, of course, but any smartphones, an application is not a rectangular button. Okay, it's a round. It has round edges. So this means handling transparency, and then you go up to 32 bits per pixel. We started from 2, remember. And of course, you need some to achieve some smooth animation, both temporal and spatial. By spatial animation, I mean expand or reduce the size of a graphical object. So this second step of the user interface, when looking at it, you see already where is the needle, and you know that you are going too fast. And for the direction as well, you have this compass which is moving and which indicates directly which direction you are going. I'm not talking about the remaining battery. It's not only a value that is changing. You have directly some blocks that indicates what is the level of your remaining battery. So that's what I call. That's why I would like to agree on what is an advanced graphical user interface. And what does it mean in terms practically for the GPU? For a GPU, what is the GPU's responsibilities in this this fancy graphical user interface? So first, it's bitmap copy with transparency. So we need to handle the transparency, and this will apply to these elements. So for fonts, of course, because fonts, to have a smooth displayed font, you need some transparency information to perform some what is called anti-aliasing. For this one is a bitmap with transparency, because you want to see what is behind as well. And as well, it's the same for this needle part. So this is bitmap copy with transparency. OK, fine, one feature. Color filling. Color filling, this graph that shows, not sure exactly what it shows, but let's say it's the altitude. So you are going very fast. And this is only, OK, setting the value of pixels and output a graph. So this is only color filling. But again, this is a heavy processing where you have a lot of pixels to set the color to. And then we come to the interesting part, which is the bitmap geometrical transformation. So I was talking about a spatial animation. That's what I was referring to. So it means resizing, so upscale, downscale. Rotation for this part. So this compass is a bitmap that we animate at runtime, depending on the direction we are going to. And also perspective, and I will come to that in the next slide. Perspective transformation. And of course, simple bitmap copy. So this one will be, you see here, there is some texture. There is, in fact, a full bitmap behind, and the elements are put on top of it. So that is the GPU responsibilities. But something we should miss regarding the GPUs I was talking before. And it's a 3D. Do we need really 3D on an MCU-based microcontroller, an MCU-based, device? 3D rendering has an impact on the GPU itself, on the structure. It becomes really greedy in resources, in memory, processing, becomes huge, generate hits. But most importantly, what is the gain in terms of graphical user interface to have a 3D graphical user interface? We are used to this kind of user interface on the 2D panels. We do not have yet, maybe the future will prove me wrong, but for the moment, the only user interface is we have, the graphical one, are on displays, 2D displays. What is the meaning of a user interface, a 3D user interface on the 2D displays? This, on your smartphone, all your smartphone have a graphic 3D accelerator. But the 3D accelerator is not used for this, for navigating through the application. They are used for specific application. Maybe you play Candy Crush, maybe you play any other 3D games. Okay, that's when the 3D accelerator is used. Why? Because the 3D accelerator is consuming a lot of power, a lot of battery. And this is not good. So for D, there is a 2D accelerator. And that being said, I say 2D, but in fact it's more 2.5D. And 2.5D can help you achieve this kind of animation. Here you do not have a 3D representation of a dice that you rotate and compute at runtime. No, you have only bitmaps for each face of the, each side of the dice, and you apply some perspective transformation to it and to display it at the right position. So these are not 3D, but they are faking 3D. And considering 2.5D instead of 3D has a lot of impact on the GPU. It drastically simplified the structure of the GPU, and it makes it suitable to fit into a microcontroller. But still, it's ready if you want to have this kind of fancy 3D, fake 3D animation. It will fit the evolution of your product as well. So, summarize the 2.5D GPU. It fits both the fancy graphical user interface requirements and keep the essence of the microcontroller. So that's not the good part. That's the dark side of the GPU. A GPU is not just an advanced DMA that we can find in several microcontrollers. It's something that requires some specific knowledge to be programmed. It can be even quite complex, even a 2.5D GPU. And then we have to decide when to use the GPU and when to use a simple advanced chroma or maybe the CPU itself. And most above all, how to design the graphical user interface. Because, okay, thank you, Nicolas, you give us a nice graphical user interface, but if I have to program all the framework to combine the graphical elements all together in the screen, it will take me ages, so I do not have time for that. Fortunately, maybe you see me coming. You saw me coming. STM32. We have a solution for GPU, and it comes with a graphic ecosystem. So there is already a 2.5D GPU on the STM32 microcontrollers. It is called the Neochrome. It's been already there for some years. The first one that was enabled with that, and it's important because it's a U5. And U5 is part of the ultra-low power family. So you see that I'm not lying when I say that we can integrate a GPU, but still keep the low power capabilities of a microcontroller because it has been integrated first on one of our products from this very family that is dedicated to ultra low power. And then, of course, we find as well this Neochrome on more recent products such as H7RS and the N6. These are high-performance products. So they are big anyway, so let's put a GPU inside. But the U5 is a good example. On this one, please visit us at our booth. You will see some demonstration running on the U5 that are quite amazing, considering that the embedded Cortex-M inside run only at 160 megahertz. On this monster, it runs at 800 megahertz. So, okay, you will not be surprised that, okay, it's fancy. But on this U5, it's a really a very small Cortex. And regarding the framework, excuse me, STMicroelectronics has a dedicated graphic framework, which is called TouchGFX. And it comes with a state-of-the-art graphical user interface design tool, so it runs on PC. And it will even run on more operating system in the future, and which enables, in a drag-and-drop way, to create all the screens of your product, really without knowing what you are doing in terms of practically, I mean, of course, because it will seamlessly use the accelerators that are embedded in the microcontroller you selected. So you just put your graphical elements, animate them, create the logic to switch from one screen to the other and come back and stuff like that. You do not have to care when the GPU will be involved, when the CPU will be involved. It will be automatically programmed for you. So please, come and visit us. Hall 4A, just there, there. And at booth 148, you will see an amazing booth on graphics and even a wall with all the demo that runs on the microcontrollers. So as a summary, I hope I gave you these takeaways. So the graphical user interface of a product should not be neglected. It's, for me, I'm convinced it is the heart of a product, and it defines its identity. So it's very important to not just put buttons and, okay, it will be okay. You have to start, stop, and raise the temperature. No, it must be more than that, I think. And an advanced graphical user interface needs some GPU capabilities. But a GPU doesn't mean 3D GPU. A GPU can be integrated into a microcontroller and still keep the key advantages of the microcontroller. But you have to consider 2.5D than GPU. And as far as ST is concerned, we have this Neutron GPU solution, along with the TouchGFX framework that can provide you all you need to implement your advanced graphical user interface. I was very quick. Oh, no, maybe not. I don't know. I have counter, but I don't know. OK, so who will be the first question? Who will have the first question? Yes. The microphone is coming.
So thank you for the presentation.
Thank you.
But how much more space is now consuming by the graphics? So for now, when you introduce the graphic, this special, how much memory taking for this part for the graphic, and how much is?
Yes, you mean driving a display?
Yes.
Yeah. You're right. Driving a display is not just adding a GPU and plug a display. You have to consider a certain amount of RAM that is used for what is called the frame buffer. So it's the amount of the representation in memory of the display the information that you will send to the display. This is the frame buffer. It's the size of your display multiplied by the color depth of the display. So yes, it has some impact on the RAM resource, of course. It has impact also on the flash resources because, for example, the TouchGFX framework has a footprint. It's not neglectable, and you do not process a graphical user interface without an impact on flash. But on devices such as the U5, for example, we decided to add 3 megabytes of RAM directly in the microcontroller, so internal RAM, and 4 megabytes of flash. And this is why, yes, when we add the GPU to a microcontroller, usually we add the memory that is needed as well. to address already some use cases, not all the use cases, of course. Then you are free to add some external RAM if you want to drive a bigger display. But you are totally right, it has an impact on the memory resources.
I have another question, if I may. What about with the generated code from this tool you show? You can tweak it, or you have some SDK or API display, or it's behind the scenes. So
no, not completely. There is a part of behind the scenes, as you said. There is a part that is delivered as binary, which is really the graphic engine of the solution. This is the one that will determine which area of the frame buffer needs to be updated. But the rest, all the widgets that are provided in source code, in C++. And the code that is generated by the tool is C++ code as well. And there is a part that is read-only because it's generated by the tool, and there is a part that is user code that you can tune to your own needs.
Okay, thank you.
And there is one question that I'm usually asked, is the price of the TouchGFX framework. It comes for free, not a dime. You do not pay. It's free to use on all our STM32 products. Sorry? Yes. For the moment, yes. It's no. For the moment, it's only on microcontrollers, and the tool itself, the designer, only runs on Windows. But it will change in the future. I cannot say more. Thank you for your attendance and your thank you.